I am back again to discuss another issue that's related to database design, and that has to do with the topic of normalization. And I have prepared some notes for you, so I'm going to go show you where I have them stored here, what folder they're in, and then you can find the notes on your own. But as I then search for these notes, I see that they are in this folder, one titled Normal Forms Example. Okay, so this is actually a spreadsheet. Now, I have not tried to upload a folder on Moodle, so I'm hopeful that I can provide you with a copy of these. If not, you may just have to look at this video repeatedly, but if it's possible to provide this, I will. And so I'm going to open this folder, and I have a web page in here, normalforms.htm, which I'll open with a browser. And when I do, it brings up the notes, and you can see, that there is a fair amount of material. Now, it's going to describe a process of organizing data within an entity. So before I get started, I want to back up to the end of the previous video. And one of the things that I mentioned was that after the ERD is created and before you actually implement it in a relational database, there's a formal process that you need to go through to at least inspect and make sure that you have the best combination of attributes assigned to each of the entities. So this, if we go back to that point in time where we've finished the ERD, we will have completed what's called a non-attributed ERD. We haven't really considered the attributes that need to go into each entity, which columns eventually need to be a part of each of the tables. So if we look through our list of nouns that we harvested from the narrative and decide among the ones that were not used for entities where the rest of them should be stored, in which entity they should be placed as columns, then we are in the process of creating an attributed ERD. And so the attributes will evolve based upon using some of the previously discovered nouns. And then as you do this, things are gonna occur to you, and you're going to discover, additional attributes that you'll want to include. And at some point, then after you feel pretty sure, maybe after talking with the end users and other stakeholders, you're going to feel fairly certain that you've captured all the individual data items that would naturally make up columns. You'll probably want to associate a data type with each column, and at this point you're going to be tempted to just take your ERD and translate it into a collection of tables and relationships in a database. But it's at this point that you need to stop and at least inspect the tables or the entities entity by entity to make sure that the columns you've chosen are going to be stored properly. And it is at this point then that you need to apply some of the material that I'm going to cover right now concerning normal forms. So what I am going to go through is a three-step process where I make refinements each step. So my initial set of rules will apply to a table or a collection of data that is not very well organized, and it will improve upon it to a certain degree. Then in the next step, the next normal form, I'll take what was refined from the first step and do further refinement to it, and I'll have an improved set of data. And then I'll do it one more time as I apply rules regarding third normal form. And one of the consequences that results from going through these steps, first normal form to second normal form to third normal form, is that I'll be generating additional tables. I'll be taking columns that really should not be grouped together and removing them and putting them into new entities. And so you can anticipate the number of tables increasing as you go through the process and the number of columns within the tables decreasing. That's just a natural consequence of doing this. So let's take a look at first normal form. And I show you a collection of data. And if I get the data in first normal form, two things will be true about it. There will be some way to identify every row from every other row. In other words, I will identify a column or possibly more than one column used in combination to serve as a primary key. The next thing that you'll see is true is that in every cell, at the intersection of every row and every column, I'll store one value. Okay, so this does not give me a particularly good way to demonstrate that, but if you could imagine here, and this is an attribute that frequently occurs, so you should be able to relate to this, even though it's not included in this particular collection of data. But oftentimes for these people things, we have phone numbers, okay, and so we have actually something called a line number here, which is very similar to a phone number, but not exactly the same thing. So oftentimes with people type entities, you know, students, faculty, employers, think of things that are really people in nature. We want to associate phone numbers with them. And when we do, there's the temptation to put those phone numbers right in with the data that, you know, makes up the rest of the data for those people like things. And that's generally not a good idea, because oftentimes these people like things, these people entities, have multiple phone numbers. And certainly one thing that you don't want to do is to have a column called phone numbers and store their home phone number, their work phone number, their cell phone number, their fax number. You don't want to put all the telephone numbers into one cell. If you have an attribute that has those characteristics where there's multiple values associated with it, you have what's called a multi-valued attribute. And there are better ways to deal with it rather than putting all the data into a single cell. Even if you're tempted to, you know, separate them with some kind of delimiter like a space or a comma or something like that, it's still a bad idea. Because if you ever have to access that data, you would have to go through some rather lengthy and difficult string manipulation to be able to pull out each of the individual numbers or to pull out a particular number. So it's very problematic to store data like that in a single cell. So there are better options, but in the very beginning, when you are developing the collection of attributes that should be assigned to the entity, you want to be heads up for that. And if you see something like that happen, then what you really want to do is take that multi-valued attribute and treat it as a child table with respect to the entity where it's occurring. So I'll come back and say more about that, but for now, when I look at this table, if it's going to meet my lowest expectation, if it's going to satisfy the condition for first normal form, then I have to have two things going on with it. It has to have some means by which I can identify one row from any other row. It has to have a primary key designated. It also needs to only be storing one value per cell. And so that's not a terribly difficult thing to do. Now, I want you to look at the headings on this just a little bit, and you'll see that there is a last name that's being stored, a line number, first name, and city, zip code, the type of employee that the person is, the pay that that type of employee receives, and related to this line, which is something that's associated with the employee, there's a either a value of analog or digital associated with it, and then also associated with this line is whether it can call in or out. So if you think about the telephones maybe that are in the lab, they're supposed to allow you to call out in the event of an emergency, but they're not to accept any incoming calls that would be disruptive when classes are going on or when the lab's being used. So they would be line out only and would be designated true. So a closer look at this, I've got a column here that relates to this thing called a line. I've got another column here that relates to this thing called a line. I got another thing here that relates to this thing called a line. And I've got a couple of columns here that are logically related, zip code and city. And I've got another column over here that is logically related in that the type of job has some sort of corresponding pay rate associated with it. So it doesn't look like I made much of an effort to parse this out according to themes. I just took all the data that I had and dumped it into one table, and in fact that's exactly what I did, because I wanted to demonstrate each of these three steps: first normal form, second normal form, third normal form, and I needed a rather poorly structured set of data to walk through all the steps. Another way of looking at this is if you follow the design process that I demonstrated in the previous video, you really should not be finding that your entities are as disorganized as you see demonstrated here. I went out of my way to create something that was just a jumble of different attributes. I want to show you one other thing here too, and you'll see that some of this data appears in red, okay, and that's suggesting that there's something wrong with it that's going to appear over and over again. And you'll notice over here that, for instance, I spell Anderson, 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 and then I attempt to spell Anderson again with an associated zip code of 46012. I spell it again here, and I spell it incorrectly. I spell it with an E rather than an N. So this red data is showing you the redundant data that is in the table. So if we structure this properly, we should be able to eliminate the reoccurrence of the city of Anderson, for instance. We should be able to eliminate the reoccurrence of 4600, 46012, and so forth. So there's a lot of redundant data in here, and misspelling something, when data is stored redundantly, then leads to some corruption and anomalies within the data that's stored. So we're looking at the data through what is called a dependency diagram. And this is not anything that I created. This is, an idea that has been around for a while. Someone else invented it. Don't know who, but it's something that I've known about for, probably 20 years. And in this dependency diagram, it shows me a couple of things. Number one, it shows me the good things about the data across the top, and it shows me the bad things about the data across the bottom. So here's how that works. First of all, again, I went out of my way to create a really disorganized set of data. First of all, I have avoided the use of a surrogate primary key field, something that I normally don't do, but I did it purposely for this demonstration. So instead of having an ID field out here and having a unique number populating each row, what I've chosen to do is to take two fields of data, the employee's last name along with the line number, which is their local telephone number extension, and that's what I'm using as their primary key. So this example again is contrived and it's a bit convoluted as well, but let me just add one more qualifying detail here. We're going to make the assumption here that two employees could share the same office, but under no circumstances would the two employees who share the office have the same last name. So I guess what we're doing is if there's the possibility of a husband and wife, making sure they don't share the same office, which is probably going to be good for their marriage anyway. But that said, any combination of last name and line number should then be unique. And if that combination is unique, then this can serve as a primary key. Okay, hopefully that's understood. Now, the primary key, if I know what the primary key is, I should be able to give the database management system that primary key, and it should be able to determine what the first name field corresponding with that primary key is. It should be able to tell me what the home city is corresponding with that primary key. It should be able to tell me what the zip code is corresponding with that primary key. If I give the database management system the primary key value, that primary key value should be able to determine the value that's in any of these other non-key columns. Okay, so that's looking at it from the standpoint of the determinant, the field that determines the values. Another way to look at it is just in reverse, where we would look at these columns that are dependent upon the primary key. Excuse me. And so we would think of these as the dependent field. So two related concepts. The key field should be the determinant ideally, and the dependent field should not be determining the value of any other field. It should just purely be a dependent kind of relationship. All right, so as we look across the top of this dependency diagram, the arrows suggest that the primary key is determining all these fields, and that's a good thing, and that's what we want. If we look across the bottom, we see that there are other arrows, and these other arrows are suggesting that we've got problems. And one problem that, if you follow this line right here and make note of this call out, one problem is a violation of second normal form, known as a partial dependency, and that's where we have a non-key attribute being dependent upon only part of the primary key. So these non-key fields should be dependent upon all of the primary key and always all of the primary key, not the primary key plus part of the primary key. So the line number, if I know the line number itself, it alone determines whether the line is a digital or analog line. It alone determines whether or not the line is allowing out-only access or in and out access. So I don't need the last name part of the primary key to make that determination. And that would be a problem that we're going to address in the next step when we transition from first normal form to second normal form. And then secondly, we have problems here that'll be addressed beyond that. And the nature of this problem is where we have a non-key attribute determining the value of another non-key attribute, or what's known as a transitive dependency. So in first normal form, so long as we can identify one row from all of the rows, and so long as we're only storing one value per cell, then we have a table that satisfies the requirements for first normal form. And this could be mapped into a relational database at this point. It would be a poorly constructed attribute or entity, but nevertheless it would work. And so what we're going to do is try to improve upon it. Now again, when I go from a lower normal form to a higher normal form, a natural consequence is that I'm going to lose columns and I'm going to increase tables. So you're going to see that happen here as I make this next transition and deal with partial dependencies. So partial dependencies, what do we have? We have rules that apply to second normal form or eliminating these partial dependencies. And here's the way you deal with any partial dependencies that you detect. You create a new table and you copy out the part of the primary key that was acting as the determinant, and you remove and transfer out the non-key columns that were dependent upon that part of the primary key. So I'm actually removing from this base table the two non-key attributes that related to the telephone thing. And so what I've really done, if you think about this, is I have, through this process called normalization, as I resolve my partial dependency, I create another entity, and everything about that entity relates to the theme of a phone. Now, I should have discovered that during the modeling process if I'd used ERDs, but if I don't use ERDs, or if I've been sloppy in my initial design, then I may be able to pick up on that as I examine the structure of the entities applying rules of normalization. And in this case, it has parsed out what amounts to a phone or a line table. Okay, and so it leaves behind now the other entities, and among these other entities we still have some problems, and the both problems relate to something called a transitive dependency, or where a non-key attribute is determining the value of another non-key attribute. So let's take a look at that as we get ready to transition to third normal form. We have a zip code. Anytime somebody gives me that zip code of 46012, it's going to relate to Anderson, Indiana. Given the scenario that I set up, where every one of these job types have a corresponding pay rate, okay, so a bit unrealistic, but again, this is a contrived example. You could think of the job determining the pay rate. So whatever job you have, you automatically know what the pay rate is. The job determines the pay rate. And that's the nature of this transitive dependency. So how do we resolve it? Well, we move down here to where I show third normal form. And what I do is, again, I'm gonna copy out the determinant field, okay, and since I had two transitive dependencies, I'll have two fields to copy out, both zip code and pay type, which is the job title. So I'll copy those, excuse me, I'll copy those out and I'll remove their dependent fields. So I'm removing city when I copy out zip code, and I'm removing pay amount when I copy out pay type. The overall effect is I have increased the number of tables again, and I've decreased the number of columns or attributes in this original entity. Also notice that this is true in when we go from first normal form, second normal form. When I copy out those determining fields, I really leave behind a foreign key. Okay, so when I copied out zip code, I made it the primary key of this new table, but since I copied it out, I still have it available up here. And where I copy out pay type, I still have it over here. Over here is a foreign key. So I really set up the structure so that it is conforming to the relational model. And what I didn't show you along the way, and I'm going to back up and just make note of this so we can consider the improvement here. Originally there were 42 non-key or yellow cells up here, and when I transitioned to second normal form, turns out I didn't really get an improvement in the total amount of storage space. Still had 42 non-key cells, but I did in fact eliminate the possibility for some data anomalies occurring. And then when I go from second normal form, third normal form, when I finish arranging things in third normal form, my total number of non-key cells has been reduced from 42 to 36. So that doesn't seem overwhelmingly like a big deal, but nevertheless I am actually seeing some improvement in storage. But where I really am going to see an improvement is that no longer am I storing Anderson, Anderson, Anderson and misspelling it in one of the instances with an E instead of an O. And no longer do I have the need to store faculty and their pay over and over again and run the risk of, in one case, typing in $1.99, and in another case typing in $19.90 or something like that. So by only having to store that amount one time, there's less likelihood that I'm going to store it erroneously if it's stored otherwise if it's stored redundantly. So there's my improved structure, and instead of having one table, I end up with 4 tables. And if you'll notice, the data here is primarily associated with name. It's not quite as clear, but this really is pretty much the people entity at this point. And these columns that were copied out, or you can think of them as being kind of left behind here, are acting as foreign keys. So they store data that acts as a pointer, not really data so much that is important to the entity itself. And I have another entity that relates to the phone line, I have another entity that relates to the address, and I have another entity that relates to pay. And in fact, I might want to call that employee, line number or phone number, address, and pay. So we have gone through a formal process to try to improve the way the data is stored, and the overall consequence is going to be that we're going to eliminate much of the data redundancy. And with only 1, 2, 3, 4, 5, 6 rows of data, I still see in the end an improvement of 6 cells from 42 to 36. So this is the process of normalization, and again, I would use it in combination with the modeling that was demonstrated in the first video using ERDs, and I would use it at a point in time where you have completed a fully attributed ERD. In other words, you've done everything I did in the first video, then you've also made your best guess at what attributes should be stored in each of the entities that you've created. At that point, inspect the entities entity by entity to see whether they stand the test of first, second, and third normal form. And once you have them in that state, you're ready to now take your design and actually implement it in a relational database. One final thought I have on the whole matter of normalization is this. If you use this in combination with the modeling that was described in video 1 with creating entity relationship diagrams, ERDs, then you're going to start out with data that is highly organized. You will have recognized the entities. You're not going to have a situation where all of your data is clustered into one structure. And so consequently, you probably won't even have to worry about any kind of test for first normal form. And I'm assuming that you've recognized multi-valued attributes and you've treated those as child tables. And the other thing is, if you avoid composite primary keys, which really are not much fun, and there's not a real strong reason to want to use composite primary keys. You know, there was a time many years ago when data storage was very expensive, and when it may have made some sense to take naturally occurring fields of data and use them in combination as a primary key rather than wasting space on a dedicated surrogate column. But today, you know, you don't have that kind of expense, and so you really avoid a lot of unpleasantness if you will use an auto number field or a surrogate primary key. And so if you have attended to the multi-valued attribute issue, and if you have used ERDs, and if you have avoided the use of composite primary keys, then you can bypass everything right up to third normal form, and really what you're going to be looking at that point are there any transitive dependencies? And if there are, you deal with them. And then one final note here. Sometimes we recognize that the data is technically not in third normal form, which is generally considered the preferred level of normalization. Sometimes we'll recognize that there's a technical violation of third normal form, but we'll ignore it anyway, because if we take normalization to the extreme, the natural consequence is that we create more and more tables every time we go to the next level of normalization. If we take it to the extreme, that means when we use the data, we're going to end up having to do lots and lots of joins in SQL in order to be able to do anything meaningful with the data. So what's good in terms of data storage, creating these structures that are highly resistant to redundant data, well, that's good for data storage. If you take it to the extreme, it's going to present a different problem when you go to use the data, in that everything has to be rejoined. And so oftentimes we may leave the data even in second normal form, just because we know it's going to be used, extensively with that set of data, and we want to be able to avoid joins and the costly processing and processing time that a join would entail. So, for instance, I've designed many a database where I included the address information within the people-like entity, rather than removing it into its own address entity. I've chosen to leave it as part of the people entity, knowing that anytime I use the data, I'm likely to want to have access to that address information, and so I purposely choose to leave it there, knowing that there are some negative consequences associated with the data redundancy that will result.